Hi, Miss Torres. Okay, so this is the Chapter 2 test corrections. And for the first problem, we have find the derivative of the following, and then make sure your answer is simplified to factored form. So for this problem, it's y equals 3x over 1 plus 2x squared, all of it squared. For the derivative, you'd first take this and you do quotient rule. So basically for quotient rule, what you do is you can do low d high, whereas basically you take low, which is the denominator, and then multiply that by the derivative of the numerator, which is just 3. And then you subtract that by high d low. So the numerator multiplied by the derivative of the denominator, which is 2. 1 plus 2x squared times 4x. 4x is the derivative of the inside from this original equation. So you take all of this and you do over low squared, which is the denominator, squared. And then from this, well, the bottom part would just equal 1 plus 2x squared to the 4th power. From this, you go down, and then you can take out a 1 plus 2x squared. And you can also take out a 3 actually. So 3 times 1 times 1 plus 2x squared. Take that out from this, which would just leave you with 1 plus 2x squared. Subtract by taking that out from this would just leave you with these. So you basically just have 8x squared. And then all of this is still over 1 plus 2x squared to the 4th power. And then from here, you can take these out so that you can reduce it, so that you'd have 3 times 1 minus 6x squared over 1 plus 2x squared to the 3rd power. To get from here to here, you go ahead and you basically just reduce this and this. So this becomes a 3, and then what you're left with is 3 1 plus 2x squared minus 8x squared over 1 plus 2x squared to the 3rd. And then you just do this part, and that brings you to this. So that's your answer. Okay, and then for the next part of this question, you have f of theta equals secant theta plus tan theta, and you're still just taking the derivative. So to do this, you just take the derivative of secant theta, which is secant theta times tan theta, and then add that to the derivative of tan theta, which is just secant squared theta. And then both of these parts have secant in it, so what you can do is take out the secant so that you're just left with tan theta plus secant theta, and then that's your answer. For this problem, you have to write the equation of the tangent line to the curve of this equation at this point, and then leave your answer in slope-intercept form. So for this problem, you start out by taking the derivative of this equation. So right now in this form, we have to get it so that it's y equals to make it easier. So basically you just move everything over so it's y squared equals, and then you'd add all of this to the other side. So 2x plus 2. And then since this is squared, you'll square root both sides. and then that'll give you y equals 2x plus 2 squared. You can also write this as 2x plus 2 to the 1/2 power. From here, you take the derivative of y, and that would be 1/2 2x plus 2 times 2. From here, you'll plug in from the point that you're given, you'll plug in the x value. So if x equals 7, or actually first, wait, you can break this down. So you go, these 2's cancel, so then y derivative just equals, you subtract 1 from the exponent, so that you have 1/2 minus basically 2/2, so you have negative 1/2. So then what you're left with here is 2x plus 2 to the negative 1/2 power. This is where you plug in the x equals 7. So from here, you basically have, if you rewrite this, 1 over 2x plus 2 to the 1/2 power. So when you plug in 7, you can do 2 times 7 plus 2, and then all of this is to the 1/2 power. And then from there, you go, this is 14 plus 2, so 16. So this, finding the derivative and then plugging in x, gives you your slope, which is m. So this is 1 over 4. And then you take this slope and you plug it in to slope-intercept form, since that's the form you need to find. And that equation is y minus y1 equals m times x minus x1. So you take all the information you've had and you plug it in, so y equals, or y minus this point, which is 4, equals, and then m you found, which is 1/4, times x minus 7. And then from here, you just distribute, and then you get negative 7, 4, and then you add the 4 over. So you have 16 over 4. So then y equals 1/4 x plus 9 over 4. And then that is the equation of the tangent line to the curve. For this problem, you have to use the definition of the derivative to find the derivative for this equation right here. Okay, to solve this, you have to start out with, since it says definition of derivative, what you use is, as limit of h approaches 0, f of x plus h minus f of x over h. So you take this equation, and then for this first part here, you plug in x plus h for the x value. So you drop this down to limit of h approaching 0 is 2, or we'll square root 2 x plus h plus 1. Subtract that by, this is just f of x, so you keep the regular x, so it's just square root 2x plus 1. And then all of this is over h. To go from this problem, you'd have to multiply it by the conjugate, which is 2x plus h plus 1 plus 2x plus 1. It's the opposite sign from here, so that when you multiply them out, it'll cancel out. So the denominator is the same thing, you multiply it by 2x plus h plus 1 plus 2x plus 1. And then from here, once you multiply this out, you go down and you get 2x plus h plus 1. Because when you multiply these, you're multiplying square rooted amounts. And so when you multiply square roots together, it'll give you the whole amount. So then you subtract this by, when you multiply these together, you'll just get 2x plus 1. And then all of this is over h times this, which is h times 2x plus h plus 1 plus 2x plus 1. This equals limit as h approaches 0. Once you multiply the numerator out, this will give you 2x plus 2h plus 1, subtract 2x plus 1, all over h, the same denominator. From this, you can cancel out these two numbers. You can cancel out, oh wait, no, you don't cancel out. You can add these, and then you're left with this plus this. So that goes down to limit as h approaches 0 is 2h. Oh, wait. This negative distributes into this, so this is actually, this amount right here is actually a negative 1. So yes, these two do cancel out. So then all you're left with here is 2h. From here, and then you have the same denominator, which is h times 2x plus h plus 1 plus 2x plus 1. And then from this, you can cancel out this h and this h, so that you're left with 2 over 2x plus h plus 1 plus 2x plus 1. Oh, limit h approaching 0. And then from here, what you do is with whatever h's you have left, you're going to plug in, since h is approaching 0, you're going to plug in 0 for these h's. So then from there, you'd go to limit as h approaches 0 equals 2 over 2x plus 0, because you're plugging in for h, plus 1 plus, and then everything else is basically the same because that was the only h you had there. So then when you distribute this all out, you will get this will just be 2x plus 1 plus square root of 2x plus 1 again. So that you can now add these together, which will get you limit as h approaches 0 is 2 over 2x plus 1. Since you have 2 up here and 2 down here, you can cancel these out. So your final answer as limit of x approaches 0 is 1 over 2x plus 1. This is your final answer. Okay, in this problem, we have a ladder which is 13 feet long, is leaning against the wall of a house. The base of the ladder is pulled away from the house at a rate of 3 feet per second. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 5 feet from the wall. Be careful of which angle. For these types of word problems, it's best to draw a picture and then write out what information you're given initially. So what we have here is we have the wall and the ground, and then we have the ladder. Okay, so the ladder is 13 feet long and is leaning against the wall. The base of the ladder is pulled away from the wall, so the base is getting pulled away at a rate of 3 feet per second. Find the rate at which the angle between the ladder and the wall